Here's a little more difficult constant pressure calorimetry problem. I'll start from the beginning. When a 1.5 liters of 1 molar sodium sulfate at 30 degrees is added to 1.5 liters of 1 molar barium nitrate, in a calorimeter, a white solid barium sulfate forms. Our other product is sodium nitrate. And that would be AQ. Now that I have the equation written, I need to balance it. So if I put a 2 here, that fixes my sodiums. It also fixes my nitrates, so now it's balanced. Now there's the balanced equation. We're given in the problem that we have 1.5 liters of sodium sulfate at a 1 molar concentration. We are also given that we have 1.5 liters of barium nitrate at a 1 molar concentration. At this point, I like to go ahead and calculate the moles of each reactant. So remember, molarity times volume gives us moles. So 1.5 times 1 tells us that we have 1.5 moles of sodium sulfate. And we also have 1.5 moles of barium nitrate. We are given in the problem that our two solutions both start out at 30 degrees, and it says that the temperature of the mixture increases to 42.2. Therefore, we have our delta T, it's T final, which is 42.2 minus 30, so our delta T is 12.2 degrees Celsius. We also are given that our specific heat, C, is equal to 6.37. We can get the mass from the volume of the two solutions that are added together. We know that we have 1.5 liters of each for a total of 3 liters. And we know that's our volume. And we know that the density is given to us in the problem 2 grams per milliliter. So we just need to find the mass. We know from our formula of density equals mass over volume. We know that we have a density of 2 grams per milliliter. We know that we're looking for our mass, and our volume is 3 liters. Put that liter there. 3 liters, that's 3,000 milliliters. So we'll solve for our mass. Our mass is equal to 6,000 grams. Now that we have M, C, and delta T, we have enough to find the heat for this reaction. Q for this reaction is equal to MC delta T. So we have that our mass is 6,000 grams. Our specific heat is 6.37, and our delta T is 12.2. So our Q for this reaction is 466,284 joules. Now that is for this given reaction. That's how much heat evolved. We want to know the change, the enthalpy change per mole. We didn't just make 1 mole of barium sulfate. If we look at the coefficients, it's 1 to 1 to 1. If we wrote the net ionic equation, it would be 1.5 moles of barium 1.5 moles of sulfate makes 1.5 moles of barium sulfate. So we made 1.5 moles of our product. This is for 1.5 moles. We want our answer in kilojoules per mole. So we need to change this to kilojoules. To change from joules to kilojoules, we move our decimal 3 to the left. So we've got 466.284 kilojoules. And we made 1.5 moles, so we'll say 1.5 moles. If we do the math, we get 310.9 kilojoules per mole. And that's our answer.